Hi, what I'm presenting is a Kotlin library called Plume, which is a CPG analysis library which is based on Suit. So what is a CPG? A CPG is a code property graph. This is produced from a given program. This is a three-part graph in a sense that it's three graphs combined into one. And those three graphs are the AST, the abstract syntax tree, a CFG, the control flow graph, and the PDG, which is the program dependence graph. Those combined into three makes the code property graph. And Suit, which is a Java optimization framework, which is this project, is what helps me produce and analyze the bytecode to create these graphs. And when you go to this link, we go to our documentation, which explains the project, the benefits, and how to set up dependencies, basic usage, which is essentially what we're going to be running through now, as this does also provide us with a examples repository, which is simply what this goes through. Then we have an architectural overview. So one thing to note is that this library comes in multiple parts. The extractor, driver, and analyzer. So the analyzer has not started yet. This is currently in the extractor phase. What the driver does is that it provides a basic interface, so add vertex edge, very simple, that will then talk to your given graph database. Currently we support only these three: TinkerGraph, JanusGraph, and TigerGraph. And the idea of this project is that there will be a white paper produced, and we will benchmark the speeds when performing analysis and extraction of the code property graph from source code. Against all of these databases will have their performance measured against one another. More on the code property graph is on the documentation here. As I said, here's the kind of graph we're going to expect. And etc. etc. So let's get into it. So this is the example repository, and the README basically explains everything from installing. So run install, which is just a batch file that will pull two drivers, the two libraries, the driver and the extractor, compile them and place them where they need to be for this project. So this example project is a Gradle project, and it has all the dependencies you need for all the supported graph databases and a task for each. So the TinkerGraph example, JanusGraph, and TigerGraph. So while we're here, let's explain how the TigerGraph works before we spin it up. So TigerGraph 1 uses Docker. So this is my Docker image that I created, which will then load up the schema on start time. The schema looks like this. The whole drop everything and create a new schema, etc., etc. All the queries you need. Most of the construction happens directly through the built-in endpoints. So let's run this. While we do this, we can run the in-memory TinkerGraph example first. So essentially, we use the driver factory and we choose which graph database we want. As you can see, we have TigerGraph, JanusGraph, TinkerGraph, but for this one it's TinkerGraph. And we give the class path, so this is the root of the program, and then the file that we want to load in. There are a bunch of files over here, example programs that we can read in. We can either give it the Java or the class file or directory containing either, and it will extract all the files. Since it reads on JVM bytecode, if we give it a source code, it will then compile it to the class file first. We then, once we've loaded everything, we will project the graph onto the graph database, and since TinkerGraph is in memory, it allows us to serialize it into files, which is like an XML file, JSON, or cryo. So while the TigerGraph one is working, Cool, done. It'll produce this graph, and using some tool like Cytoscape, we can look at the XML file. Let's find that file. Here we go. And here we have it. So let's have a look at the source file. So basically it's a equals 3, b equals 2, c is equal to the sum of those two variables. So having a look at this, the blue edges are the AST. One thing to note about the CPG is that it also aims to be programming language independent. So something like class and file structure work differently in Java. So we go for a neutral variant of it where the methods go off of the packages. The source file is linked to the package, but the source file edge is a separate idea. Then we can look at this. Init is our constructor. So simply calls the initialize and it goes to the return. And this is the object produced, the argument. And as we can see, our modifiers here. And here's one of our the args, the string, Java string args, our local variable, all as a parameter. As you can see, the type of this is method parameter in, and the CFG will show the flow of the program. So I'll first assign a equals 3, b is equal to 2. As you can see, here are our local variables, and here's a program dependency edge. Basically, we have one local, and here, and the rest are identifiers. Every instance we mention these. Then we go to the last assign, which is the addition of a and 3. Oh, sorry, a and b equals c. Then we go to this return, which will then go to the method return, which is a void return. For convenience, I have loaded an example of a conditional. So let's look at the conditional. It's pretty much a, b, a is equal to b, then we have subtraction, else addition. As you can see, is the two assigns. Then we go to the if statement, which has a condition edge. Yeah, it's greater than, as you can see, our greater than. We have the assign of the subtraction. This CFG edge goes down the subtractions, and this on the false goes down the addition path. And then two of these roots end at this. One thing you note that obviously this is hard coded, so there's only one path that will actually happen in this, but for the sake of soundness and we sort of sacrifice a certain level of sort of just saying how we generalize the flow, and we can do perform analysis and prune the graph later for something like constant propagation, where we can propagate these constants here, see that one root will always be true or false, and we can then remove dead code or detect dead code in analysis. And then we return something like a loop, simple while loop. You can see here, we enter the body, assign, if we go along the true route, we go assign, and then it comes back to the start of the if until it evaluates false, to which the program will terminate. And then a last example, which will be the switch statement. We have something like I equals 1, switch I, and result being returned, assigned to different strings, which will then be returned. So this time we actually return a value. Let's look at that. So we go to the assign, I equals 1, table, the condition is our I value, and then the case, different case values are here with default here, and as you can see, the CFG will then flow to the respective assign, result equals 0, result equals 2, etc. Our return, which returns this identifier, which identifies to this local variable, which would have been assigned by one of these assign calls, to our method return, which returns the string. Cool. So that should have given us enough time for our TigerGraph instance to be up, and it is up. So let us run TigerGraph example. The TigerGraph example, the driver just needs a bit of configuration, so this is sort of builder style configuration where we can set the host name, the port, which is just the REST++, secure, which will basically determine HTTP or HTTPS, and if we need an auth key, we can add it there, and it will add our token in the header, for example, if we're using TigerGraph Cloud. So let's run that. Okay, we are done. Let us go to TigerGraph. So I've simply written a show all query. As you can see, here is that same graph from earlier, just to refresh your memory. Let's go to this. So simply the three statements like that. And since TigerGraph is quite strict on the edge schemas, I have the name CFG there, and CFG can technically go between multiple different vertices, and then just a unique vertex for every possible permutation that is required according to the schema. So as you can see here, the packages and the different method calls. Here's a source file. So it's a bit harder to read from this view, but obviously making a custom visualizer for the Plume project is something to consider. So, and then you can analyze your program and stuff like that. So let's have a look at the schema that's loaded for you. So very complicated schema, looking at it like this, but the schema is explained in a lot more palatable sense in the documentation. So while that loads, okay, so we have about all of these vertex types, and these can be categorized either by their base traits. So here are the traits and the descriptions, and vertices can inherit these. In Plume, the driver creates the base traits as abstract classes, and the vertices are data classes, and none of the edges hold any properties. This is another design decision that makes it that is from the original shift left CPG schema. Another thing to note that this code property graph comes from a white paper by Fabian Yamaguchi, who's now the chief scientist of shift left, and they have commercialized this idea with their own TinkerGraph graph database. But the original schema can be found here, and the different edge types and constraints. So for example, these control flow edges can only go from the source to these targets. Vertex types can also be categorized into where they occur in the program. So program structure, we'll see namespace blockouts, our packages, our files, our class files, and members. And type declarations, method header, method body. These are sort of vertices that we will find here. And then something like metadata, there's also an unknown vertex for very language specific vertices. Talking about language support, this currently only supports analyze JVM bytecode, specifically Java, but this will have a look into, say, examples like Kotlin or Scala, but also Python code compiled to Jython, and we will see how that goes. Here's also instructions on how to use the different backends, how to configure our driver, so details, instructions on how to set everything up, the use cases, and the Kotlin docs are here. So each part of the library has Kotlin documentation, all the classes, how everything works. Same with the extractor. And that is Plume.